Sorry, it's clearly going to be one of those days. Let's take a look at what's going in the car in more detail, since that last bit was probably a little bit difficult to understand because, well, I was being distracted by not feeling well. Okay, here's your car. Force of gravity is down on it. Friction force is what's holding it up. The friction force has to be equal to the gravitational force on the car, which is equal to mass times the acceleration due to gravity. The friction force is also equal to the coefficient of sliding friction times the normal force. In a centrifugal force universe, you have a centrifugal force this way, normal force this way. And the centrifugal force, we know, has to be equal to mass times the velocity squared over r. The centrifugal force also has to be equal to the normal force. At this point, you have several equalities, two pairs of equalities really, that have interconnections. And you can answer a host of questions about this situation. If you know the coefficient of sliding friction, you can find, for instance, for a given radius of arena, the required velocity. You could, if you knew the velocity and the radius of the arena, you could figure out the coefficient of sliding friction, etc., etc. One of the things I'd like you to do while you are watching this lecture is perhaps pause now and take a minute to observe that the mass of the car drops out. The mass of the car ceases to be important. So I'm going to let you work on that one independently, and you will see it again as an example in another problem in just a moment. All right, so using a centrifugal force framing, we can talk fairly intuitively about what's going on, what forces are balancing each other off, and find that there are a number of equalities between them that enable us to make meaningful calculations about how to construct this system, how hard to press the gas pedal down, and useful things like that. The centripetal explanation is a little bit harder. And here's kind of a stab at it. This is going to probably strain your visual imagination a little bit. But we're going to jump over to the top-down picture in order to understand what's going on from a centripetal force point of view, meaning from the point of view of us in a Newtonian laboratory, a non-accelerating frame in which we recognize that there is no centrifugal force on this thing at all. There can't be. We observe that the car, if the wall were suddenly to disappear, would not in fact fly out that way, but would in fact continue this way. So here's the idea. The car has an inertia which is carrying it in a straight line path. It can't go in that straight line path, because if it were to go in that straight line path, and now you understand that I'm drawing this as very big chunks, but this is actually a continuous, this argument is actually a continuous set of very small infinitesimal sections of wall that we're considering. But I'm drawing it big for purposes of, well, because my pen's only so small, and the camera only is able to see so much. So, as my car is attempting to move in a straight line forward, it finds that at a certain point it can't. It collides with the wall of the arena. when it comes into this sort of collision contact with the wall of the arena, it is sent inward. So here's a normal force. This is not normal to the tangent. Let's try that again. The force that's normal to the tangent at this point is a radius. That's back to that 9th grade geometry, and I've drawn it badly. But when this car collides, we will have a force arise which is normal perpendicular to the tangent of the circle at that point. That normal force, therefore, is continuously pushing the car on an inward path and is providing the centripetal force that we are experiencing. You'll notice that that means that we have an equivalence to this situation here. In this situation, we have a centripetal force that's equal to the normal force. In this case, we have a centrifugal force that's equal to the normal force. No matter what, they have to be equal. In this situation, we can still make meaningful calculations regarding friction and everything else, but it's a little hard to understand where that friction is acting, what direction it's acting, because we are no longer thinking about the car sliding up and down as readily. We're now kind of thinking about the car as repeatedly colliding with the wall as it attempts to move in its straight line direction. At this point here of collision, where the normal force from the wall arises to push the car back into the circle, then we have a friction force that acts in this case for this view of the car up and down into the piece of paper.